Okay, now does anybody remember when you're factoring? So my directions for all of these problems are to factor. We are to factor all of these problems. So I'm going to have 2y squared plus 2y minus 60. Now when you're factoring, there's a couple things we need to look for before we start factoring. The first thing you want to look for is that you're in descending order. The other thing that you want to look for is, well, these are not equations, we're not solving, but when we get there, when we're solving, it has to be set equal to 0, can't equal anything else. And the last thing is that we want the leading coefficient to be positive. We want the leading coefficient to be positive. So does this fit the criteria? Is it in descending order? Yes. Is the leading coefficient positive? Yes. We are good to go. Who remembers, before you do any other type, before you look for dots, before you start looking at factors, what's the first thing you have to ask yourself about this expression? Bina? Good. You're looking for a greatest common factor. That is your starting point no matter what kind of factoring it is. So looking at this, is there a GCF here? Is there a number that's in every single term? Yeah, what's that number? 2. If that number was just in 2 out of 3 of the terms, could I pull it out? No. Can it be a variable that's a GCF? Absolutely. Can it be a number and a variable? Absolutely. So we're going to pull out that 2. So then we are y squared plus y minus 30. So now that we've pulled out that GCF, we are looking for factors of negative 30 that add to a positive 1. Who thinks they know? Factors of negative 30 that add to a positive 1. Anthony, right?
Yeah, 6 and negative 5.
You got it. We are positive 6 times a negative 5 is a negative 30. Positive 6 plus a negative 5 is positive 1. So now we are y plus 6, y minus 5. All right, let's keep going. Remember, my directions for all these problems are to factor. Can I pull out a GCF of 3? No, because 3 is not divisible by 8x or 5. It's not divisible. So now we have to think, this is a different kind of factoring. I hate reviewing this kind of factoring because if there were 10 different Algebra 1 teachers, every single one of them would have taught it a different way. So I want you to do it the way that you learned it, right? The way you spent a month doing in Algebra 1. I can show you sort of the general guess and check that is like the baseline way to factor these. How many people learned earmuffs, where you take the first and the last and multiply those? Did anybody learn that way? No? You did? Who did you have?
Mississippi.
Oh, Mississippi teaches earmuffs now too? I knew Mr. McCarthy did. Anybody else? You did too? Okay, so I think I know earmuffs, even though it might be a little bit different. So I could refresh your memory on earmuffs. I don't know, some teachers did some kind of X. I don't know the X. I don't understand the X. I don't know the X. So I can't refresh your memory on the X. So you're sort of on your own with that X. All right, so general rule. Basically, if you understand this, the way I'm showing you, it's actually the best way to factor, because when I throw more complicated problems at you, it sort of goes back to this initial thing that I'm asking you to do in your heads. It's sort of a guess and check method, but there's strategy to it. So we know we're trying to multiply back to this product, Do we agree? This is what we're trying to multiply back to. So the beginning of this is pretty easy. You ask yourself, well, what two things multiply to 3x squared? It's nice when it's a prime leading coefficient. So what's the only things that multiply to 3x squared? A 3x and an x. There's really no options there. So we're going to have a 3x and an x. Okay, so this is sort of where the guess and check comes into play. So now I want factors of +5. This is also nice because it's prime, right? The only factors of a +5 are +5 and +1 or -5 and -1. Do we agree? Okay, so here's where the guess and check comes in. We know we need to add to a negative number when we check out our multiplication. Since we're going to need to add to a negative number, do you think we're using the two positives or the two negatives? The two negatives. So the two positives are out. So this is where I'm saying there's like strategic ways of thinking about this. So these two numbers are out. So now we have -5 and -1. So I could put the -5 here and the -1 here, or I could put the -1 here and the -5 here. Do we agree? All right, I want to do it the wrong way first. I'm going to do it the wrong way first. So I'm going to put the -5 here and the -1 here. What we now need to do is we need to check this middle term. I will show you how to check this middle term. To check the middle term, you take the first x with the second constant. What's 3x times -5? -15x. Then what you do is you take the first constant with the first variable. So the constant in the first parenthesis with the variable in the second parenthesis. What's -1 times x? -1x. Then you check. What's -15 minus 1x? -16x. Is that -8x? No, we need a -8x. So that doesn't mean these factors are wrong. That means I need to try to now switch them. So now we switch them. I'm going to put the 5 here, and I'm going to put the 1 here. And now I'm checking again. How do I check for the middle term? You do the first variable with the constant in the second, and the constant in the first with the variable in the second. That's how you check. So now I'm going to do a 3x times a -1. Isn't that -3x? And then I have a -5 times x, which is a -5x. What's -3x minus 5x? -8x. Isn't that what we wanted? So this is our factored form. 3x minus 5 times x, the quantity of x minus 1. Do you want to see me check this? Does anybody want to see me check it? Good, because I don't want to check it. All right, let's do another one. Adam, you okay? Earmuffers. Do you guys want to see earmuffs?
I'm not really sure what earmuffs is anymore.
Okay.
Just multiplying it over the,
Did she maybe call it the AC method?
No, I don't.
Okay, so then I'm not going to show you so I don't confuse you more, okay? So let's do another one. What number was this? 2, 3, 24x squared minus 16x minus 30. Sean?
My teacher did what she calls the kid with a crayon method.
What's the kid with a crayon method?
I don't know.
Is it the factor by grouping?
It's just like she called it like 5-year-old with a crayon, like fill it in and just check.
Okay, there you go. Whatever works. Okay, so here, no matter what type of factoring problem it is, where does your mind immediately first go, no matter what? What do you look for? A GCF. Is there a GCF here? Yeah, what is that GCF? 2. So I'm going to pull out a 2. So now we're going to have 12x squared minus 8x minus 15. Are we still factoring with a leading coefficient? Yes, we are still factoring with a leading coefficient. And it's not as nice. Why is this not as nice? There are many factors of 12, right? We have 1 and 12. We have 2 and 6. We have 3 and 4. Many factors of 12. Where do you guys want to start? 2 and 6. I think that's a good starting point. So keep your GCF in the front. So we are 2x and 6x. Okay, so now what we're looking at is we are looking at factors of negative 15. So factors of negative 15, I'm not going to put the signs in yet, okay, just factors of 15. We know are 1 and 15 and 3 and 5. We don't have that many options, right? Again, I'm not worried about the signs just yet. I'll bring the signs in a little bit later. Do we know, at the very minimum, the signs will have to be one positive, one negative? Okay, so now let's look. We're going to have one positive, one negative, and when we check this part back out, we need to get to negative 8. So I'm sort of like doing things a little bit in advance in my head. If I take that 15 and I put it here, 2 times 15 is 30, right? And then 1 times 6 is 6. 30 and 6, any combination of that, will that ever get me 8? Never. So 1 and 15 are not my go-tos right now. Let's check 3 and 5. All right, 3 and 5. Let's put, let's put the 5 here and the 3 here. All right, we're gonna put I'm doing it wrong. 5 here, 3 here. All right, and I'm gonna check it. So we're gonna do 2 times 3 is 6. 5 times 6 is 30. 30 and 6. Any combination of that ever give me 8? No, but what can I do with the 5 and the 3? We can switch it. So let's switch them and see. Okay, so we know 2 times 5 is 2x times 5x is 10x. 3 times 6x is 18x. Is there a combination of positive and negative between 10x and 18x that could give me negative 8? Yeah, which one do we want to be negative to give us negative 8? The 10x or the 18x? The 18x. So what gave us the 18x? 3 times 6x gave us that 18x, right? So that means I'm putting my negative with the 3. And then that means this is positive. So this is going to be a positive 10x minus 18x, which gives us the negative 8x. And this is our factored form. Okay, I'm going to give you one to try on your own. Try this one on your own. So I will tell you the biggest issue with this next coming test is going to be time. You need to be quick at factoring. And the only way to get quick at factoring is to repeatedly factor. So if this stuff, you're still like the basic stuff, you're still like not as quick as you'd like to be at it, all you have to do is more problems. Like you could literally Google, factoring with leading coefficients and millions of problems will come up. Just keep doing them. That's how you get quick. So as long as you understand the concept right now, like that's my purpose. I'm to make sure that you understand how to go about doing it, and then it's on you to make yourself quicker with it. All right, so who has the factored form of this? Next to Adam is Brandon.
5x
times x plus 7. But we need to multiply to a positive 7.
Yeah.
So you kept it with plus 7? All right, let's check it.
No, he said negative.
Oh, he said negative 7? I thought he said plus 7. Oh, good. Negative 7. Perfect. Who wants to see this? Who wants to see why this is what it is? This is correct. Don't be shy. We're good? Okay, let's keep going. Okay, so what did I do? What did I tell you Algebra 2 is? I told you Algebra 2 is Algebra 1 just really stepped up, right? That's all it is. So every Algebra 2 concept is some Algebra 1 concept bulked up. So let's bulk up a little bit. It's not even by much. Okay, so an ideal factoring scenario is something that looks like this. You have a trinomial, but the exponent on the second term, on the variable in the second term, is always half the exponent on the first term. Or you could look at it as the exponent on the first term is always double the exponent on the second term. Is that the scenario? Is the exponent on the first term double the exponent on the second term? Yeah, so that means this is a good factoring scenario. So what a lot of kids prefer to do is they don't like to work with the variable in the exponent. So we use substitution. I say, okay, let's let a equal the lower exponent, x to the m. If a is x to the m, guess what a squared is going to be? X to the 2m. So this gives us 6a squared plus 19a plus 15. Is this something we know how to factor? We should. All right, you all factor it and then let me know once you're done with your factoring. Are you done already? Okay, let's let everybody else catch up. If you need help, raise your hand and I will come help you. Do you have a question?
Oh yeah, do we have to set it to A? Like when you say that like
We cannot leave it like it is. Do you have to use the substitution?
Yeah.
No, you don't have to. You can easily factor without using the substitution.
You have to like put the x set 2m back when you're done.
We're going to put that back. Yeah, I'm going to talk about that once we're done with the factoring part of this. Who wants another minute for the factoring? Who wants another minute for the factoring? All right, Angie, tell me, what'd you get?
Well, 3x to the n plus 5, 2x.
Okay, so great. You factored back, you substituted back in. If we didn't, let's say we would have gotten 3a plus 5 and then 2a plus 3. So if you factored using the a, what we're doing now is right now, this is in terms of a, but was my original problem in terms of a? No. So now, once I factored, I have to substitute back in. A equals what? A equals x to the m. So anytime I see an a, I'm going to substitute back in an x to the m. So this is 3x to the m plus 5 and 2x to the m plus 3. So you have to substitute back in. All right, we don't get intimidated by the exponents. What do? We look at the exponents and we ask ourselves, is this first exponent double the second exponent? It is. So can I factor this? Yes. Do you have to use substitution? No. Can you use substitution if it makes you feel better? Absolutely. So if you're not using substitution, you sort of just figured out they're both just going to have the second exponent. You sort of just figured that out. But if you prefer to use substitution, easy peasy, we're going to let a equal x raised to the n plus 2 power. Well, if a is x raised to the, not n plus 12, n plus 2. If a is equal to x raised to the n plus 2 power, then a squared is x raised to the 2n plus 4 power. So then we're going to have a squared plus 7a plus 12. And then we factor. Factors of positive 12 that add to positive 7, positive 3, and positive 4. If this were the test, would you be allowed to leave it like this? No, you have to substitute back in. That's actually one of the biggest mistakes with substituting, forgetting to substitute back in. So now remember, a is equal to x to the n plus 2 power. So I'm going to have x to the n plus 2 plus 3, x to the n plus 2 plus 4.
When the equations equal to 0, how do you do it for if you have like raised exponents?
That's not this chapter. That's next chapter. So we'll get there when we get there. It's a little bit more complicated. That's actually even after we're going to then mix exponents into it because it gets a little bit more complicated. So that's why I can't show you now. Okay, so here we have 2x squared minus 11xy plus 5y squared. I've now added in another variable. That's okay. we're going to go about this the way we would just with normal factoring. Do we agree the only things that multiply to 2x squared are a 2x and an x? And now we have a 5y squared. Well, the only things that multiply to 5y squared are 1y times 5y and negative 1y times a negative 5y. Do we agree? Well, now look, when we're going to have to check things, we're adding to a negative. So am I using the two positives or the two negatives? The two negatives. Now, we need to get close to 11, right? Do we want the 5 to be multiplied with the 2? Or do we want the 5 to be multiplied with the 1? If we're trying to get close to 11. We want the 5 to be multiplied with the 2. Do you see how strategically you could move this along quicker just by thinking? So here I'm going to put, I need the 2x to be multiplied with the 5. So I'm going to put the negative 5y here and the negative y here, and then we'll check it. 2x times negative 5y is negative 11xy. When there is more than one variable, the general rule is you put it in alphabetical order. When there's multiple variables, the general rule is alphabetical order. So that's why I put the x before the y. So now we're going to do the negative y times x. Negative y times x is a negative xy. Oh, I put negative 11. This was a negative 10. Sorry, guys. Nobody caught that? What's negative 10xy minus xy? Negative 11xy. Do we have our winner? Yes. Okay, so I'm going to add another level to this, which isn't really hard. It's just another level that you need to check. The very first thing, no matter what type of problem it is you have to look for what? No matter what kind of factoring, you always look for greatest common factor first. You are never done. So now I'm adding something. So in the beginning, we're looking for GCF. At the end, you never think you're done until you make sure nothing else can be factored further, because we're going to be factoring further. So what do I mean by that? Let's look at 4x to the 4th minus 24x squared plus 20. Is this okay factoring? Our first exponent is double the second. Is this okay? Absolutely. This is okay. My first exponent's double the second exponent, so we can factor this. I'm actually not going to use substitution here because I think this factoring is pretty easy, right, with the x squared and x to the 4th. So I'm not going to use substitution. But first thing we're going to look for is a GCF. Is there a GCF? Yes. What is our GCF? 4. So I'm going to pull out a 4. So then I have x to the 4th minus 6x squared plus 5. Okay, so now we come to factoring this. So now what multiplies to x to the 4th? It's not x and x. What is it this time? X squared and x squared. Don't put x and x. That will mess you up. So now we are x squared and x squared. Multiplies to positive 5 but adds to a negative 6? Negative 5 and a negative 1. Everybody okay with how we factored this? All right, now I added a new level to your thought process, right? After you're done factoring, never think you're done factoring. What do I mean when I say never think you're done factoring? You look in your parentheses and say, can I factor this anymore? X squared minus 5. Can I factor this anymore? No, the only option would be a dots, since it's x squared and a minus, but 5 is not a perfect square, so that's out. What about x squared minus 1? Yeah, this is a dots. X squared's a perfect square, 1's a perfect square, There's a minus in the middle. So we need to factor that further. So now we are at 4 and then x squared minus 5. And now I'm going to factor this, x plus 1, x minus 1. Never think you're done. I'm going to ask again. Now, is everything factored to the point we cannot factor anymore? Yes. So this is our final factored form. All right, let me give you a couple to try on your own, and then we will call it a day. Oh, what was that? So for number 10, I would use substitution. For both variables. That's my advice for this one. You don't have to. That's just my advice. Yes.
How is the second variable half the first?
For which one?
Okay.
Number 10. So you're looking at the different variables separately. So you're looking at the x's. So the x is an a plus. Oh, sorry. That's my fault. This one should be a 2a plus 2. There we go. Good catch, Bina. Thank you. Guys, I'm sorry. I should have put a 2a plus 2. I miswrote it for number 10.
If it was just A, then would it be half of A?
If it were a, if the exponent on x was just a, then the other one would have been half a, yeah. How are we doing on time? Ooh, we are too short on time. Okay, bell's gonna ring in 2 minutes. Let's go over the answers, and then we can go over the problems next class. So for number 9, can someone tell me what did you get for your factored form, your final factored form? Bina. 2y plus 3z. This is perfect. And again, if we need to go over it, we'll go over it next class. What about number 10? Can somebody tell me? This one was a little bit more tricky. Once you substituted back in. Angie.
2x to the a plus 1 plus 3 divided to the a plus 1 plus 5.
You got it. All right, guys, we will go over this next time.